So before pulling the engine, I did a compression test at operating temperature using a blue point or snap-on gauge, and the results all came back very positive, between 176 psi and 187 psi. Now this gauge does tend to read higher than other gauges I've used, but in comparison to my Z4 engine, which I've compression tested with that gauge, this 180,000 kilometre engine only recorded readings on average about 5 psi less. So very strong compression from this engine and consistent across the cylinders. And the engine and transmission are out of the car. Got the sump off, and I knew it had eaten the serpentine belt through the front main seal. There's bits of rubber in there in the sump. Some other bits and pieces up here. I think some of this is some sort of gasket material they've used as well. No major bits of belt, but yeah, that's bad enough as it is. So there are bits of serpentine belt in here, and it's come through the front main seal there. Just started pulling down the motor, and the first thing I wanted to do was check the journal for the big end bearings, and yeah, they are perfect. So all the rod caps are off, and the journals there are perfectly shiny, and the bearings that came off, no hot spots, no scoring. It's in excellent condition. I took a sample of the engine oil and sent it away to Caterpillar for used oil analysis. Now keep in mind that I have no idea what brand of oil, what grade of oil, and how long it had been in there for. But when the analysis came back, I noted that the iron, copper and aluminium ratios were pretty much identical to my other N54 engine, although slightly elevated, and that could just be to longer oil change interval. The silicon level was very high, sometimes be dust or dirt contamination, but in this case I think it was the previous owner using a lot of silicon gasket maker to try and seal the valve cover gasket, and some of that found its way into the oil. And finally, the detergent package of this oil was quite different to what I've usually used, as that was expressed in higher calcium, magnesium and boron levels. Here I've laid out most of the major engine components to give you an update on the engine build progress before the engine starts going back together. So let's start with the bottom of the engine here. The bed plate is in great condition, nothing wrong with it, so that just got cleaned up and that'll obviously go back in. The block itself also in great condition. The bores were excellent. We're retaining the 84mm bore, but they've been honed to help with the new pistons and rings that are going in. The top of the block here has been decked about 1/8 thou just to clean it up, and that's about 0.2 of a millimetre. While we're on that, the head gasket that I'm going to be using is the stock BMW N54 genuine MLS style head gasket. They do make these in the stock thickness as well as a thicker one if you do face or deck the block any further. However, I'm trying to boost compression slightly, so happy to stick with the stock thickness one. Also on the block here, I'm going to talk about some of the other things I've done, but before I do, I'll just point out that I'm going to have links in the description below for more detailed reviews and steps on some of the major changes I've made here. So please check that before asking questions. Check that description. So the engine has M11 bolts here in the center, and the four corners are M9 bolts, this little baby M9 bolt here, and that becomes a known weak point of the N54. When you start pushing higher horsepower, it has a tendency to lift the cylinder head, mainly because of these smaller bolts here. So to overcome that, we're moving to ARP 2000 head studs, which is a better idea because obviously the metal stud screws into the aluminium, but when we're torquing it, we're really putting all the pressure on the threads of the stud rather than the threads of the bolt into a different metal. So head studs here, M11 from ARP 2000. Head studs, there's the part number of them there. I do believe they're only available or sold or distributed through VAC Motorsports, so look out for those. In the corners here, we've upgraded to M11 from the M9, and so to do that, we need to drill it out. But we haven't just drilled it out to M9, I've actually drilled it out a lot larger, and we've got this insert here. This is like a big, long helicoil. Now, once again, there'll be a link in the description below to a video on that process. So big NS300L inserts will go into the four corners, also to then use the M11 head studs all around. Closed deck here, so the N54 is an open deck by design, and my tuner Ken at Wedge has strongly suggested closing the deck, and I was very skeptical of the idea of using this epoxy product, but yeah, after talking to him, my confidence has increased slightly, and seeing that it is a common way a lot of the Honda guys were doing it. So yeah, got myself some of this epoxy. We've used that, drilled holes in it, and so now we've got effectively a closed deck design. So along with the upgraded head studs and the closed deck, gives me confidence for the 700 or 800 horsepower we're going to be pushing. Shouldn't have any problems in those departments. In regards to the pistons, this is one of the stock pistons and rods that came out of the engine, number 3. Interestingly, they all sort of were in this sort of condition and shape. No bent rods, no cracked ringlands. This one had a little bit of a bright spot there on that side of the piston. The direct injection is above, so I don't know that it's been washed off. Maybe if somebody has any ideas on what might cause that, let me know in the comments. Yeah, this is one of the stock ones. The ring gap is part of the problem with them. So the stock ring gap is too tight for the higher horsepower. The ends of the rings come around, touch each other, and then crack the ringlands. It's probably more going to be the top compression ring where that happens there, but yeah, that's a known problem with them. And the rods can bend, so as soon as we start pushing over 600 wheel horsepower, better chance, there's a reasonable chance of rods bending. So they need to be upgraded, and they are being upgraded with Manly H-beam rods. So there's the part number of those there. So a Manly H-beam rod with a 3/8 ARP 2000 rod bolts, should give some extra strength on there. The pistons I'm going to use are these Marl Motorsport pistons. There's the details of those there, and they're a forged piston, so forged rod, forged piston, and this combo should easily be able to handle the 700, even 800 wheel horsepower if I end up at that level. I had originally ordered these pistons from Marl in a 9.5 to 1 compression ratio, as that's what I thought I needed for the high boost application and the potential later to do port injection only. But after talking to Ken at Wedge Performance, he convinced me to look for a higher compression ratio piston. So luckily I was able to change my order to these 10.2 to 1 compression ratio pistons, which are more like the stock compression ratio. As far as bearings go, the stock bearings were all really good. My initial review of them or check of them, I thought they were perfect. They're not. You see, this one's the worst one, but there is a fair bit of wear on the top shell here. But otherwise, they're not too bad. They're definitely not really, there's no risk of them spinning or anything like that. The main bearings were actually near perfect, so probably might have got a little scratch or two on them since I've taken them out, but they were in excellent condition. So the main bearings there will get replaced with these King bearings, and there's a bit of a backstory about how I came to obtain these. And in Israel, here to pick up the parts, the King bearings, made in Israel, right? Yeah, made in Israel. Yeah, thank you very much. Thank you, guys. Thank you. See you later. Good luck. Bye. Yeah, so I couldn't find anybody in Australia or the US with stock of those main bearings when I needed to order them. But I happened to be in Israel, and so I contacted the factory and had the bearings delivered to a little shop in Tel Aviv where I picked them up. On the rod side, on the big end side, also going with King bearings. These are sets of pairs, so you need 3 of them. CR222SV, they're a stock size bearing, so they'll be the bearings that we're going to use. Over to the crank. The crank was in excellent condition. I have polished all of the journals and checked them. They are in excellent condition. Probably got a bit of dust on them now. They've been sprayed with WD-40, but they're all in really good condition. At the end of the crank here it's a forged crank too, so no need to upgrade or change that. That should easily hold the power that I'm planning. At the end of the crank here is the crank hub, and this becomes another weak point or potential weak point of the N54 engine when we start pushing above probably 700 horsepower. It's a little bit of Russian roulette if you don't do anything about resolving this, but this crank hub goes on the front here, and these sprockets, or one of these sprockets, drives the camshaft chain, the cam chain, and they spin independent of the hub, and the hub can spin independent of the crank. The whole thing is just held in with one big bolt and a lot of ugger-duggers, a lot of torque, and there are some little friction plates or friction discs, washers between these sprockets to help stop them spin independently. And obviously if this spins, one of these sprockets, or the camshaft sprocket here, spins independent of the crank, then we have an interference issue, timing issue with the valves hitting the pistons, and a major engine catastrophe. So to overcome that, need to use a one-piece pinned crank hub. So this is a single piece. These sprockets are part of the whole unit, machined out of one piece of material, and at the end here, these pins here are going into these 4 holes that I've drilled in the end of the crank. So then it will get bolted in there, and there's no chance of the camshaft sprocket turning independent of the crank. So this comes with a kit with a guide and a bolt and a drill bit. Bolt that on, and just with a cordless drill the holes out. The process is quite daunting, but in reality, now that I've done it, I wouldn't hesitate to do it again, even with the engine in the car. The position of the holes in relation to like a clock face really doesn't matter, because the timing of the camshaft is not determined down here, it's determined up at the sprockets on the vanos at the camshaft. So it doesn't really matter what position these holes are drilled in. The cylinder head is the top of the engine here, next part we'll talk about. So I forgot to mention when filming this that the cylinder head has had about 7 thou taken off the face. That's in addition to the 8 thou off the block deck. A few things we've done to this. So I've drilled these corner holes out for the M11 head studs, and the bores for the injectors were corroded, so they've been drilled out, tapped, and got this injector bore repair insert in all of them. And so the sleeve here goes in, gives us a smooth surface, nice good sealing surface for the direct injection injectors. And so they've all been drilled out. Some of them don't have the insert in it yet, but I'm currently working with the Dremel here to take off the excess thread. So this one down here has the insert in it, and you see there's a sharp edges of that. I'm concerned about pre-ignition coming from that, so I'm using the Dremel to just grind that down and smooth it off, so there's no sharp edges as a source of pre-ignition. I will be planning to run port injection along with the factory direct injection, but later, if I choose to go port injection only, then I need to delete the direct injection holes here, get rid of them. And so that's where this insert kit I think is pretty nice. And just unscrew the bore repair insert and swap it for a DI delete plug. So just screw this plug in, and that blocks the injector port. This one here, it's got one of those screwed into it. It'll just look like that. The top of the cylinder head here, I'll just pause here to mention that the brass exhaust valve guides were replaced by the engine machine shop as a precautionary measure, just due to a bit of excessive free play. It wasn't blowing any smoke on cold startup, but I didn't want to have any trouble later. Also made some changes. The BMW N54 has a PCV system that collects oil residue in the valve cover above this and then dumps it into the intake ports through these little holes here. 1, 2, 3, 4, 5, 6. And that creates a problem in the intake runners with oil going in there, carbon buildup. So I'm planning to block these and run an external PCV system. You don't need to block them just to run the external PCV, but because I'm going to push 30 PSI boost, that's the main reason for blocking them. So they've just been drilled and tapped. A grub screw will go in there, and when I make 30-pounder boost in the intake runner, it won't push that 30-pounder boost up in here and try and dislodge my valve cover gasket. So just for the sake of the integrity of the valve cover and the valve cover gasket, those head ports needed to be blocked. And on top of all of this goes the camshafts inside of a cam tray back down here. These are new cam trays, or clamshells as they're also known. The ones that came off were slightly worn, and where they wear is just on the ledge on the end here. The pre-Feb 09 engines have a steel or metal gasket or ring at the end of the camshaft, and it basically runs in here and creates a groove on that ledge, and that then leads to Vanos oil problems or oiling problems for the Vanos and changing of the valve timing. So as a preventative measure, although they're only half worn, I'm going to put new cam trays on. Here's the original stock sump. It's just been cleaned up a bit, and it's going to get this baffle welded in. This baffle here comes from AAF. There's the details. I bought it through Turner Motorsport, and that will get welded in there around the digital dipstick, and that will help offer a little bit of protection, not much, but perhaps a little bit of protection under heavy braking where the oil wants to slosh forwards towards the front of the sump, maybe holding some at the back of the sump when I'm braking at the end of a quarter-mile run, and maybe give me a little bit of extra protection there. The other modification to the sump will be the addition of an old school dipstick. So the digital dipstick will remain, but I love the idea of being able to pull a dipstick and check the oil level, as well as checking the oil condition, making sure it's not milky, etc. And so this is just a generic dipstick. There's the part number. I'm going to machine up a little bit of this aluminium bright here, and that'll get welded in the side and come in down here. So I'll make a future video on that process, so check for a link in the description on when I make that. At the top of the engine, to cap it all off, will be a valve cover, but possibly not this one. This is an aftermarket aluminium valve cover that I bought new from ECS Tuning. It arrived and it was broken when it arrived. A little tab or something snapped off back, was broken off back here. But to be honest, this is a piece of junk. I think I'd much rather pay a little bit more money and just get a genuine OEM plastic one. Yeah, they're available through ECS as well as, I think, China, eBay type suppliers. I think they probably all come from the same place. So in some ways, I probably bought the most expensive version of the same piece of crap. But if you do buy one, be aware that they have lots of imperfections, so I don't think I would install this straight out of the box. You'd have to run a reamer around the edges of everything here, because there's little bits of, hard to see, little bits of aluminium like that might just easily, well, there you go, see, broke off and fall inside your engine. So you'd want to run a reamer around all of that, maybe soda blast it as well, pull all the cyclonic separators apart on top. And even here I did notice there's even like little bits of machining swarf that are caught in the groove here, so you'd have to carefully go around, clear all that out so that it seals properly. But I'm going to try and return it to ECS for a refund, just based on the fact it was broken, and maybe try and just get myself an OEM plastic one, or maybe an OE style plastic one. And here we have a small selection of a lot of the other smaller internal engine components and some external components that I've bought. Now, it wouldn't all fit on the table here, but I've gone ahead and bought everything like Vanos solenoids, boost solenoids, valve guide seals, inlet and exhausts, coolant hoses and lines, valve cover, sorry, not valve, oil filter housing gaskets, timing chain guides, timing chain, even a genuine BMW timing chain. They probably never fail, but we've got a new one anyway. And lots and lots of bolts, genuine bolts. Some of these are aluminium bolt kits of aluminium bolts that have to be replaced, as well as even some individual steel bolts. So these are just a few of them. And for the savvy accountants keeping track of the budget, at the top we have the money spent in the first two parts of the series, and underneath is the breakdown for this part 3 video. Now, I'm only including the cost of items or services that I've actually used, excluding any freight or import taxes. So items like the rods and pistons will get included in the budget only after they've been installed. The budget remaining is just under 35,000 Australian dollars.